So the first step that you need to do if you have a Pharo image downloaded is that we need to get the Git repository in some state that you can commit to it. And so that is to be done by first making sure that on your own Git you have some kind of clone of the main repository, which I have here. And it's not actually important that it is new, so you can see that this is really old, 1000 commits behind, but you need to have one so that you can actually do a pull request to the main repository, because on the main repository you don't have any write access, and so with the GitHub model, the idea is that you commit to your own repository and tell GitHub that there is a pull request waiting for the maintainers to look at. So if you have made your clone, then you can actually in the Git tool kind of bring the predefined repository in a good state. And what I do is that I use a fresh image always, and I just use that. So that means I clone again everything. So you do that by saying repair repository, clone again, and then you put in this dialog, you make sure that you're on GitHub, and you put your own repository. So, for example, my repository name, then Pharo, and then it will actually clone the whole thing, which is, with a modern machine with SSD, astonishingly fast. So one can actually do that quite frequently. There is another way of having one clone on your machine and to reuse that, which is another, but I often just make it fresh. So this is now nearly done. Always takes a little while, and then we hope that it really works. Yeah, looks good. So now we get detached working copy. The reason is that the image is in a different state than the main repository, because there have been already things committed or something like that. So you need to repair repository again and say create new branch from image commit, and then no, that was wrong. Yeah, you need to do that, and then you name it something. So I always say backstop, so that I know this is the one that is like the empty one that I can always go back to. And if we now save this image, then we have something that we can use to do work. For example, if we go back to the Pharo issue tracker, then I made up some easy issues today that we could try to fix. So for example, this one here it's a simple one. So while browsing the system, I saw that the method pass34, which is actually not a nice name, and we should think about maybe we should rename it, but I was looking at it and then I saw that it actually calls the parser directly, and if an error is, it returns nil. But then we do have actually a method on compiled method, which does something very similar, and it's called has a very similar name. It's called parsetree. So if you look here, some extension method. So this one actually does the same thing. It returns an AST for the method, non-cached, because that is what you get when you ask for AST. The only thing is that the fallback is a little bit different. So when it it does not care about errors, because it thinks that the code should be fine, which I guess is the same here, because we get the code from the method, so it has been already once compiled, so there cannot be an error. The only error can be that there is no source code, and what we do here is that we decompile in that case. So that means that I guess that we should better reuse that method and not do it twice. It's always nice to have things at one place and not at two. So that means we could replace this one with self compiled method add, symbol pass tree. I'm quite confident that it will work, but we will see. So the question is, maybe there are some really strange side effects or odd things that will make this not work. But I guess it should be okay. I think this is one of the methods where we don't have a test for. Do we have a test for this? I don't think so. Which we should maybe fix, but let's see if this works. Object, pass3 for halt, boom, works. We get back a pass3. So that means that should be fine. So if we would want to now commit this, we would first check if the change was okay that we did. So this one looks good, nothing else. And then we had on our issue tracker, we have an issue number for that. So that is 4001. And so that means that we can actually use here the GitHub tool to say create new branch for issue, so that we don't need to do that by hand. Here it's a bit bad that it's not really visible that we need to select, so pre-selected is my own repository, and we need to select the Pharo repository because that's where the issue tracker is. We put 4001 there and it automatically suggests a name, so that tool is just there so that I don't have to make up a name that is nice. I say accept, and so now I can commit. So I commit. And the idea is that one always, it depends. If it's something really trivial, you just say fixes for 0, because then you can look at the issue tracker entry, what it was. And the nice thing is that actually GitHub will automatically close the issue when the thing gets merged. But then it often makes sense to actually describe what. So because they say pass3 for should reuse the method pass3 on compile method. And then we can commit. After committing, so it's now committed to the local repository on my machine. When we push it, it gets pushed to the repository on GitHub, my own repository. And so that means it's now on my own repository, but so that it actually gets submitted to Pharo, we need to actually say create pull request. And there you need to put your credentials of GitHub. And thankfully we have this all in a way that we can do that with live streaming without showing any passwords. The menu is a bit strange. This is, I think, already a bug tracker entry for Git, for the Git tool. So we first press OK and then accept, and it will work. And you only need to do that once, so it saves the password for the next use. So now it says what it will show, create pull request, and if you come back to the browser, it will actually be already updated. You can click on the pull request, everything is there, and there you now see what we did. So we replaced the reference to RB parser by reusing the method on compile method. What now happens behind the scenes is that we configured Git to have a couple of tools included. So the first one, which is already green, is the whip plugin. So this means that if I would call my pull request with the name VIP, or if I would use certain other phrases, I don't know exactly which, but VIP works, for example, then it would disable merging. So the idea is that this way you can actually do a pull request where you know that it should not be merged, but that you would want to just show it to other people. Then there is the minimum review plugin. So this one will be green if someone reviews this pull request. And I can show you how to do it, but I'm not allowed to review my own pull request. So that means that someone of you needs to do the review instead of me, for real. And then the last one, and this one is actually quite slow, is the real test run of everything, and it's even more than a test run. So what it does is it checks that this is mergeable in the latest version, because there could be intermediate things that get merged that lead to to failures of merge conflicts. So that is the first thing. So it merges. Then it actually does a full bootstrap of the image. So that means it does not load that into the last image that you would download yourself, but it really does a full bootstrap of the whole system. That means it builds the whole Pharo image from the Git repository, like the Pharo image is built all the time. And then it actually runs all the tests on all 3 platforms, which takes all in all quite some time. So now you see here, it fetched everything that it needs, and now it does the bootstrap. And it does it in 32-bit right now, so not in 64-bit testing. So all in all, this whole process takes around 30 minutes. And if the load is high on the build server, a little bit more. And out of that, I'm not sure, maybe 20 minutes is test runs. I'm not sure. Could be half, could be. So it's a bit long, but in the end, it's quite usable. And the idea is that this allows us now to commit something like this, where we are not 100% sure if it will really work, because it might be something really deep in the system that relies on the strange behavior of the old method. But if this would now, if we will look later at the build, so if the build succeeds and the tests run, then you can be very sure that it actually will work. Because it means that you could actually create the whole, so the compiler could compile everything, a lot of things. And if you run all tests, that means you have really a high confidence that you didn't break anything. So the next thing is reviews. So what happens is that pull requests end up being listed here. And the idea is that we do not want to integrate anything without having looked at the tests and without that someone looks at the code. Reviews are of course not easy, because the idea is not that you should, as someone coming and looking at the code, the goal is not that you get as proficient with the code that you could actually do it yourself, the same change. I mean, that would be an insane amount of time for a review if you would say, yeah, but I would have done it differently. If you reach that stage, then something might not be wrong from the time budget that you invested. So the one thing why a review is important is that you want to check that people don't do any bad stuff. So because imagine someone would merge a fix which says delete the disk of the user. That would of course be a real problem, because that would delete your disk after the next time you run the project. And so that means that people need to read the code to see if it's not complete crap that is done there. That's one thing. The other thing is that you need to check that only that is done from what you can say, what the person says that he did. So that means that it looks correctly. So it's that if someone says, I fixed the compiler, that it does not have changes in the graphical user interface and things like that. And these things happen not only because people do it because they want to do it, but it might be that doing the pull request could be, there could be something have gone wrong, and then there could be strange things. So that what you do when you do a review is that you look, so the first level is that you look at the code in GitHub. Which is a bit odd, because you would think that this would not work, considering that the tool is very different than a Smalltalk code browser. But interestingly, it's amazingly workable as a review tool. The second thing that you can do, which I show later, is that you can download the image and play with it. That's possible too. And we did have in the past tools to actually load the change into your image to play with it, which we should get back to. But actually, it's amazingly okay to have these two levels of the image with everything installed and the code itself. So for example, here you see that someone wrote a test. And then you see that there are a little bit of changes. like some if nil check in case of something is anonymous, and nothing else changed. And so that means that it's in sync with what this change does. Or if you look at our own change, and we click on Files Change, and we see that it really only did the change that we wanted to do. So that looks good. What you can do for reviews, which is nice, is that they have an integrated review tool. So that means that and here you see that I'm not allowed to approve my own change. But the idea is that you can click on the Approve button and say that you think it's a good change or something like that. The idea is that both you doing the review and then later people looking at the reviews and the change to decide if it should be merged will of course take into account your reputation. So if someone reviews that we have never heard of, then we will of course give that review not a huge weight. So that means that I would then review myself in addition, for sure. But if someone reviews that I really trust and that I have seen 100 reviews being done and they were all good, then there might even be cases where one doesn't need to check as in detail, because one knows if that person reviews, then it's okay. The idea is that as more reviews there are, the easier it is to decide that to integrate something is good. So, for example, for the change with the traits, anonymous traits, we could do that. So we go to Files Changed. First we look at the thing. So we have one comment, it would be cool to backport this, that's already good. So and then we could say, okay, this looks good. And then we review. GitHub does give the people that have write access to repository, they are a bit more important for reviews than others, but that's only for GitHub. For us, it's important that people review. So if we have 2 reviews of something, then we are really sure that something is most likely good. So there's that. The other way of reviewing, and I think we need to take the same thing. So one thing that one needs to always check is, of course, you see here the continuous integration build and test run did run and it failed. But often it fails because of spurious failures that we have not yet tracked down. So sometimes, for example, here the Unix slave did not want to run, no idea why. But if you look at tests, it should tell us that there are no problems. Yeah, all 41,000 tests are green. So that's nice. So another thing that you can do on the issue on this view is that this is where you can download the pre-built image with all the changes inside if you want to test something yourself. So if someone says, "Oh, I fixed this bug," you look at the code and say, "Yep, that looks maybe good, but let's see if the bug is really fixed." Then you can download the image and play with it. So the image is actually directly up here. Due to so it's called Pharo 7, and even inside it's called Pharo 7, but it's not. So the reason why it's Pharo 7 is that when the whole setup was started, it was started in Pharo 7, and the idea back then was to remake, when we do Pharo 8, to rename, to have 2 different names, but it turned out that this is far too complex, and the real thing that we should have done is we should have called it just Pharo, this bootstrap for the tests. So it's not Pharo 7, it's really the build that was done for checking all the tests. So if you download this, you get an image, and then you can run it and play with the change. But it tends to be not that often that it's needed to be done. So it's more for interactive. So if someone changes interactively something, then it might be interesting. So for example, we do work on the code completion, and there we actually downloaded the image and checked that it didn't break anything really grave. But often it's okay to merge things without checking them, because it's kind of clear that either the test will fail or it will be good. Like, for example, with the parser change, that's something like that. So that is that. Are there any questions? Any questions? Do we do one more? If there are no questions, we can do another one before stopping. So this one is nice. How does this apply for fixing documentation? So documentation, so there are some documentation in the image, and there it's actually the same thing, that you would update the thing with a pull request. Other documentation might be the same. So the only thing that is different is, so if you look at the, where is, oops. So documentation, it's often on GitHub too. So all the books are on GitHub. Pharo, there's a Pharo wiki with some stuff. I think the wiki has the problem that it's a bit hard to contribute because GitHub didn't implement it correctly. But then there is another Pharo documentation project, which is a GitHub repository that is easy to change. So it's often the same thing, that you can contribute by doing pull requests. If not, or if you don't know how, you can add an issue tracker entry, and then we will help you to fix something. For example, if you go to pharo.org, if you want to add something there, it's sadly something that something that is easy to change for us, but only not everyone has an account there. So that means that if you want to have something changed there, you need to make an issue tracker entry or send a mail. But issue tracker is actually quite nice for these things too. So if you add an issue here in the sense of please fix this on that web page, that can be done quickly. Or if you say, oh, I would like to contribute to that book, where can I do it? Then people can answer that question too. So let's do another example. So we can continue to use the same image. So that means we do not need to make a new image. We need to only get back to the backstop. So we need to get this one out of the image and back to a state like before. And that you do by checking out the backstop branch locally, which just undoes the change that we did before. And now we are in an image like the state that we had before doing anything. So that looks good. So the idea was that I wanted to explain a bit what I want to show. So if you inspect the slot, let's do that. If you inspect slot, the class, then you get a class inspector. But the class inspector for slots has one special pane, which is called all defined slots, which shows you all the slots that the system defines. So a slot is, to explain it, so if you look at for example, my example that I always use for slots, if you look at point, we have two instance variables, and traditionally in Smalltalk, as you see here, they are described with a string. But of course, that's a bit sad, because they are not strings. They are there should be objects. So that means that traditionally we have an API that we can ask for instvar names, and we get a collection of the names of these instance variables. But that's all not nice, and so that means, and that's the reason why we actually changed this, and where Pharo really is not Smalltalk anymore, is that you can actually that we actually introduced the concept called slot, which is like something like an instance variable, but not an instance variable, because potentially it can do more. And if you ask point for its slots, then it answers you to objects. And you see that they are both instance variable slots, so nothing special. But of course, you can subclass slot the class and do whatever you like to do, strange stuff. And people did that, and so we have a couple of examples in the image. So one that is used a lot is, for example, the spec observable slot, which is used in the spec framework to update, to have it's an instance variable automatic update notification to the client. So that is nice. A bit sidetracked, so we have that. It would be nice to add the same for this class variable. So class variable are a bit the same. So if you have, you can add a class variable here to any class, and it's a certain kind of variable that is accessible on both the instance side, class side, and not only on the instance side. So it's used a lot, for example, in Smalltalk image. We have a lot of them for configuring things like the image path, the compiler class, and things like that. And there, it's the same idea that in Smalltalk, they are strings, as you can see. So there's one big string, and the only way of talking about them is about names. But that is a bit sad, and so we actually changed it. And it's an object now. So if you could do a Smalltalk image, let's put a dot there, class variables, then you get the definition of those variables as objects back, and you can do stuff with it. For example, you can look at the using methods of this. But the sad thing is, if I now inspect a class variable, I do not get any all defined class variable subclasses, because if you look here, subclasses, there should be somewhere. Let's check the hierarchy. There's one, but it's a subclass of literal variable. So it's a subclass of a superclass. But there is one example. So we have an example where we defined a new kind of class variable, where we changed what read and write means. Yeah, so they are there. But it would be nice, and that means that it's more literal variable that we should inspect. It would be nice to have an inspector that shows us all the subclasses of literal variable, like we had for slots. So if we look at slot, we have all defined slots. It would be nice to have an inspector like that. To get that, we browse slot, and because we talk about the class side, we check there, and then we find a method that actually does this. So this GT inspector all slots. I hope this is not too fast again, but we will see. So we can actually just do what we want to do by copying that over this method and changing it little bit, because it's exactly what we want. So let's copy that. Let's go to literal variable class on the class side. Boom. And all variables in better name. Then we say all defined variables. The other is the same, all subclasses, only that we want to filter out ourselves. No, we want to only show it when we are on the superclass itself, so on literal variable. So that it's not shown on the subclasses, but only there. And so now, if we inspect, we should actually get, boom, all defined variable tab there. With example class variable, the one that I guess, I mean, we have globals are their own variables, pool variables, undeclared workspace. They all are kinds of variables. Yeah, it's a question if this is good to show all these internal ones, or if you should only show things like this one, but that's for the future. So we now have a first step. It's good for me to play with this. The reason why I want it is because I'm playing with the API of the variables and the inspector. So if you now look here, then you have all refs, but that only shows you direct references to this class and not the references where the class is used. And so I want to improve that so that all the references show something else than that. So it's more a tool for myself and a tool to make it a bit more consistent with everything. The idea is that every time you inspect the superclass of some kind of variable definition, you should see all the defined variables. We have the similar for pools. So if you inspect shared pool, this one here, then it shows you a tab where it shows all the pools that people use. So for example, the most famous one is text constants, I think. So you see here that if you import the pool dictionary definer text constants, then you have access to all these variables at once. I personally don't like pools a lot, but they can be useful for, especially when you talk about low-level stuff. So for example, we see it used a lot in constants for FFI and things like that. Yeah. Another example. Good. So I guess you get completely confused because I always explain things that have nothing to do with the change that we did. So the only change that we did, we added this inspector for literal variables. That when you inspect the class of literal variables, that it will show you all the possible variables that people defined and that you might be able to use in the system. So that's good. Which means we can again do the same thing than before. We can take this number, say create branch for issue on the removed repository, not mine, accept, and we say commit fixes 4003, added inspector pane for variable, maybe move it to class variable later, things like workspace was not interesting. Here, so a small comment that maybe one can improve it a little bit more. Then we say push. And create pull request. And it's done. That was a second change. Are there any other questions? Another question is, would it make sense to do this kind of fixing stuff live? Does that make sense? I mean, would it make sense to do that more often? I mean, there is a slightly different form that one could do, is that one could more have the goal of trying to fix something together. So to say, oh, let's maybe even define some issue beforehand and then meet and do something where the text chat is more used. Another idea could be to do this more regularly. That one says, okay, let's just, because it's, I mean, people do that anyway to do fixes and to review stuff, and so maybe one could just do that with a live stream more often, if it makes sense. I mean, is it can people understand it? Is it too fast? Is it too strange? I can show you why this inspector is interesting of all defined slots. So if you now go to, with slots it's already working, so we go to all defined slots, and then we know that people use it, so then you go to spec observable slots, and then you go to slot users, and then it shows you all classes that actually use this odd way of instance variables. So for example, maybe this one is nicer, notebook page. So there you can see it has one normal instance variable, and then title is an observable slot, icon is an observable, layout is an observable. And observable is right now, if you browse it, you can actually see what happens. So read actually, so it's the idea is it's a wrapper right now. So it actually wraps the value in a value holder. And on read, it gets the value out, and on write, it puts the value in. And at some point, it actually does and then the thing that is actually wrapping the whole thing, the value holder, actually does the announcing when the value changes. So it's actually quite interesting. That means that this allows you to build, to kind of hide away a lot of boilerplate code that would be normally there inside of something much more general that everyone can reuse, which is quite nice. Other slots that we use is, I think the only other one is this one in an example. Which actually models the idea that if you have an instance variable pointing somewhere else, that the other one could point to you too, and that it would be nice if it would automatically update. So this is a relationship implementation using the slot idea. Yeah, good. So it was possible to follow even at my speed. That's nice. Oh. Yeah, so I guess from my side that is for now everything. Next time, so the idea is that the tech talk I will try to be regular of organizing a tech talk, in the sense that it will be someone showing something, some project or something like that, or giving a lecture like the one that we had about artificial intelligence in the past. And if nobody has anything good to do like that, then the fallback will be always to do something like this, to just do some fixes or review something. But I'm thinking of maybe we need to see, maybe at some point we can even split the two, because I think tech talks are can be something else than just doing some live bug fixing. So if it's really useful, one could actually do that more often. Now that the setup works, that could be an idea. Good, good. If there are no other questions, how many people did actually watch? I have no idea. Not a lot. But that's fine. So then I would say that is it for this time, and we will see what to do next. So the next one will be, I think, I'm not sure if in August, because August is holiday time and there is ASOC at the end, so it might be only in September. And for then we have already someone, I think there will be a presentation of GTK framework. Good, that's it for me. You can ask more questions in the Discord channel. I will be online for some 10-20 minutes, I think.